name is Landon. This is Charge Tape Lab Physics 2, Lab 1. Right. So, introduction. The purpose of this lab is to see how excess charges exist and transfer through bodies. It's the transfer of electrons. This will decide how charged the particle is. We see in this lab that protons do not move, electrons do, and when those electrons move, it leaves net charges on both of the bodies in the interaction. Now, we're going to simulate this phenomenon using Python through GlowScript. In the results, we're going to see that the two pieces of tape which we tore the third piece of tape off of, are then positively charged and repel each other because they both have the same charge. The charge on each piece of tape was 1.35 times 10 to the negative 8th coulombs. Each of the two pieces lost 8.46 times 10 to the 10 electrons. This means that they lost that amount of electrons and then had a positive charge as a result. Fundamental principles, we got that we treated these as a point charge. That means that their electric field is centered at the center of their area, their center of mass, and this will decide. We can use this to then calculate the forces that it exerts on other bodies. Of course, these are positively charged. So we see in the upper left corner right here that they're going to have an E net outward from themselves, and because it is a positive force, that E net will then have a force that is in the same direction. And you can do the second law. This is F net, right? We're going to look at, how much did they move whenever they were looking at each other. Of course, they're static at the end of it. So we know F net equals zero. However, we can look at the forces involved. One of the two are gravity and electric force, and then we can calculate the electric force over that because we can already calculate the gravity using the mass of the tape. And of course, with that electric, we're going to use Coulomb's law, which is K, Q1, Q2 over their distance squared. Our assumptions here is that we neglected air resistance and humidity. We treated each tape as a point charge, even though they both have an area, and both pieces have the exact same charge. Experiment setup. So we took two pieces of tape, we ripped the third one off. This removed electrons from those the two layers that made up the base tape. All right. The So that's essentially the setup. The system is the upper tape. Right. We're gonna see how that interacts with the lower tape. Now the upper tape refers to the one that got ripped off of, not the one that was ripped. It's the one that is one of the positive charge ones. The lower tape is surrounding, because then in order to find the charge of the two, we had to compare one to another. Therefore, made one of them our system, one of them our surroundings. We made the Earth the rest of our surroundings, because anything that it touches would be grounded, and its charge is relative to the Earth, which is neutral. So, our observations, each piece of tape repelled each other because they were both positively charged. We said that they lost electrons when being ripped by the third piece of tape. The upper layer of tape attracted a negatively charged pen, showing that it was positively charged. This pen had an excess of electrons, making it negatively charged, and of course we were able to see that it did not take electrons from the third ripped off piece of tape because it attracted this. And it was attracted to my hand because my hand was neutral and it polarized my hand. If any body that comes into contact with a non-neutral thing will make a dipole out of that neutral thing. It carried the positive the electrons in my hand closer to it than attracting it, making my hand a dipole. Diameter measurements tape mass was 0.002 kilograms, 0.2 meters, 0.02 meters. Uh, so with this, we just have to get the force of gravity using the mass of the tape. We find the charge of the tape using Coulomb's law, right? So we knew the force because we knew the F net. If we know the force of electricity, we can then derive it from the electricity thing. So see, at the bottom here, we got 1 over 4 pi epsilon naught times q squared. Q squared because it's the same charge, because the two tapes have the same charge, and then d squared, the distance between the two. We derive the q from that, therefore we got our last charge, additional data, the number of atoms. We took the surface area of the tape, surface area of the atoms. That'll tell you how many you can fit. Charge of the tape, charge of the electron. This will show you the number of fission electrons. Now, this basically shows you what the net is and why it was positively charged, because how many electrons you'd have to lose to get to that charge. Ratio of electrons to atoms. We just did 1 electron to every 1.54 atoms. We got that just comparing our two numbers. Flow script code, I mean, this is pretty simple. We just put in our constants, our objects, our R vector in order to put it into the F electric and gravity acting on top tape. That was through just G times the tape mass, same F equals mg. calculating the charge of each tape, we just use Coulomb's law, electric force, same thing. All right, data versus model. Of course, in the data, we're going to have uh, some human error. Some things are, the distance might be a little bit off. There's humidity, there's stuff we didn't take into consideration with the model. Of course, there's that. If, like specific, we know everything has a theoretical conclusion of which we got to in there. If you compare the two, of course, we're going to see that where some of the human error came in, the humidity that we treated as point charge, that kind of stuff. What if the electrons had a positive charge and a negative charge? This would just swap everything would be the same as far as like how it would attract a hand, how it would attract like a neutral object, and of course something with the same charge. The only thing that would be different is something that already is negative, then it would be negative, then they would attract. And then why is it important? Because it will ground and then become more neutral. When it grounds, its excess electrons or lack of electrons will then transfer to make both objects more neutral. Conclusions. You can charge any charged body, treat them as point particles, and practically measured through the net force. If I take the net force in the electric, we can do the same derivation we did in this video and in this lab. Thank you.